Okay, so the other thing is same thing. Now we'll be looking at notebook and oops, something is happening here. Dismiss. And let's try to run this again, see if it loads up. And it's complaining. Dismiss, and then we'll refresh it again to see, or we can just do Jupyter again, run it again. Let's see if it works. Okay, Google Drive, I have it mapped, computers, laptop, and York University. And I think this is week 5, so go to lab, whatever your folder is. Let's see if this runs. Okay, so same thing. Whatever I was talking about earlier is what it is here. Obviously, when you do through a Python, profile, it is much easier to assume. So once again, the NumPy, pandas, and these are standard libraries. You could just always run it or always have it. And as I mentioned, the Monte Carlo simulation is used to estimate a risk probability or risk of the business given some variables. Um, you have to be mindful that in some cases it may or may not be normal distribution, it may be something else. So try to understand the distribution and you can assimilate it. So in this particular example, kind of like similar what we did on the Excel is calculating projected revenue, and we define revenue as price times units sold. It's just established thing. So if your price is 100 and units sold are 1,000, your revenue is going to be revenue times price times units sold, and print revenue. This is just a simple function. You can run it again here, and that's it. Like if you um, so you can bound these results into a data frame. That's how Python works. And it looks like it ran. Yeah, I think it ran. Okay, so I'm just going to for you to ignore this. Okay, let me reset the kernel here so that you don't get confused. Okay, and let's clear output as well. Okay, perfect. So let's run it again here, and this is just the definition, and we ran this earlier. We'll put this in a data frame. Okay, so what this is doing is exactly the same thing, and I'm just going to break down the code here. It is assuming a normal distribution, and this is the mean, and this is the standard deviation, and this is the probability function. Mean, standard deviation, probability function. So obviously, it is simulating 10,000 times. Remember, we just simulated 20 times and 10 times on the Excel, but you can always put a function like this, and this is iterative. For function means it loops through like 10,000 times. It will not stop until it runs 10,000 times. So that is the beauty of the thing. So let's run that again. It will, it knows revenue has been defined as price times units sold, and it will iterate multiple different times. So let's run that here. And it should be running, and it is complaining about some indices. So let's see, and sometimes it gives some error, but okay, so it is running. Sometimes it just gives you error for no reason. I've tried that a few times. Okay, as you can see, it is quite an extensive iteration, so it almost 10,000 iterations, so it definitely ran. As you increase this number, it'll get slower and slower. It almost take 30 seconds, right? So if it's a little shorter, it will be a little shorter. But again, we'll ignore that for now, and let's run this here. Plot. And the distribution kind of looks like normal, right? So based on this run, we didn't run this. We'll ignore this for now. It's just same thing we're doing for 20, but you can see the normal distribution. So looks like revenue, most of the revenue is going to be around here. There's going to be some here, and there's going to be some here. You can also find the results function to find the describe, and you can understand the data here, right? So again, every time we run, it's going to be a little different, but you can look at the median value, you can look at the 75% quartile, um, you can look at the 100% quartile and so forth. So just be remember, like, this data is not going to be exactly here, because every time you run, it's going to be a little different. So you can also look at the visualizations of the projected revenues from a histogram point of view, and, like, price, unit sold, something fun, exciting, descriptive. You can also look at a lot of outlier events. So it looks like there's going to be some outlier events in here, quite a lot actually. Same thing with the revenue plot, some outlier events. And you can also look at the frequency distribution, sorry, probability distribution here. And it's going to run, and looks like, most of the stuff is going to be here with the area under the curve. I don't know why it is showing up. Everything should be under. So you can also look at it from different distributions. So, on Excel and on this one, we did normal distribution, but you can also figure that out on a like a triangular distribution for this case. Same thing, describing the data and so forth. So I challenge you to try it out, and I also challenge you to see when you can use, let's say, exponential distribution or triangular distribution or binomial distribution, that kind of stuff. But if that's too much now, but think about it from your company's point of view. There's some distributions that are more suited for industrial uses, but when you're looking at profit and loss and things like that, it is mostly going to be normal distribution. So once again, I wanted to bring the Excel component as well, and try it out. So don't forget to try this out yourself, and don't forget to try play with the parameters, understand the code and things like that. Hopefully this is of some help to get you started. Thanks a lot.